Alright guys, here we go with another video. Today I'm going to show you how to enter in equations into a graphing calculator, and I'll also show this on Desmos a little bit later. So for right now I'm going to do this on a graphing calculator. I have a TI-84 Plus, but it's pretty much the same directions for a TI-83, any model, and TI-84 any model. If you have a TI-85 or 86, you might have to Google how to graph these on those. All right, so what we do, what we're having to do here is to sort of explore what is the end behavior of these different functions. So first off, what is the degree of a function? So the degree is just the highest exponent on the variable. All right. So this one, even though it's not written down, the highest exponent is 1 there, so it has a degree of 1. This one, the degree is 2. This one, is the degree is 3, etc. All right. So we're going to see there's some kind of the end behaviors of these different degree polynomial functions. So let me go ahead and you'll notice the first one, or the second one here, I guess, is a quadratic. The first one's already done for you. You have to write down the range, the end behavior, and then do a rough sketch of the graph. All right. So this one's a quadratic. Let's just put it in. I know we've seen this before, but let's just go ahead and see what it looks like here. So I'm going to put x squared. So again, here's the, let me move this up a little bit. So here's the x button, right, and then that puts a square on it there. And we get the higher powers, we're going to have to use a different button, but for now that works. All right, so now we go to graph this, and there we go. Use Desmos to find the end behavior. Well, first let's go to Desmos. So desmos.com, and then click Start Graphing. And let's go ahead and enter x squared here from your table. So hit x, and then to make the cursor raise up, to put it in an exponent, you have to hit Shift 6, which will activate the little caret symbol there. And then hit 2. There we go. There's x squared. So the range we can see is from 0 to infinity, right? Y value of 0. This ranges is y values, right? I'm not asking, the domain's already written here for you. So range is the y values, bottom to top. So from 0 to infinity is the range for this one. The end behavior, well, so as x goes to infinity, meaning as you go towards the right, what does y do, or what does f of x do? Well, it goes up forever, so we put infinity here. What about as x goes to the left, negative infinity? As x goes to negative infinity, y goes up also. So these are both positive infinities, all right? And then we'll just do a rough sketch of the graph here. So you can just get your calculator screen and just quickly sketch it. Don't spend too much time on this. Okay, there we go. All right, let me do one more with you guys. I might do one from down here. Let me just pick I don't know, like negative x to the 5th here will do. All right, so this is going to be a degree of 5. All right, and let me go ahead and put this in the calculator. So I hit y equals there. I hit y equals to get to this menu, and then I'm going to clear that, and then I'm going to put in negative, not minus, negative, which is near the bottom of the calculator here. All right, and x, and now we can't use the squared button this time. To put in higher powers, you use this button right here. It's called a caret. Okay. So like that, and then we put in a 5. If you want to get out of there, we don't really have to here, but you might have to do this later. You just hit the right arrow, and it sort of gets out of the exponent. Okay, now we hit graph. Let's see what this looks like. All right, interesting. So we need to do the range. Well, the range, again, bottom to top, it goes all the way down, all the way up. So it's going to be negative infinity to infinity. Okay? And then the end behavior, so as we go to the right, it goes down forever. So as we go to the right, that means y goes to negative infinity, right? So as we go to the right, as we go to positive infinity, y, or f of x, is going down forever. All right. The other one here, as x goes to negative infinity, as we go to the left, what happens to y? Well, it goes up forever, so positive infinity. And then we'll just do a quick sketch of the graph here. So draw this here, and it kind of looks like it goes something like that. Okay? All right. So that's what you're doing here. Alright guys, you should have finished the end behavior table on the previous side. Now we're just going to sort of quickly summarize the results there. So the odd degree polynomials, that would be like x to the first, x to the third, etc., x to the fifth, x to the seventh, and they had a positive leading coefficient, right? So positive x to the first, positive x to the third, etc. You might have noticed the same end behavior. So I went ahead and just drew the sketches here. This would be just a linear one, and then if it was high, like a x to the third, x to the fifth, it had some curves in it, something like this. But the end behavior is the same for all odd degree polynomials that have a positive leading coefficient. Okay, meaning that that term that has the highest exponent has a positive leading coefficient, or a positive coefficient. So the end behavior for these, as x goes to infinity, y goes to, well, let's see here, x goes to infinity, y goes up. X goes to infinity, x goes to the right, y goes up. So y goes to infinity, okay? I think it might have been f of x on the other side, but it's the same idea. All right, so as as x goes to negative infinity, let's look here. As x goes to negative infinity, in other words, it goes to the left. What happens to y? Well, it goes down. Okay, same thing here. As x goes to the left, y goes down. So y goes to negative infinity. All right. So what about the even degree polynomials that were positive, like x squared, x to the fourth, etc. Okay. What did those look like? Well, here I just made a general sketch. They kind of look like this. So end behavior, as x goes to infinity, as x goes to infinity, y goes up. And as x goes to negative infinity, y goes up also. All right. And then what about if you had a negative leading coefficient? So these would be like, negative x or negative x to the third, etc. What happened here? Well, it just basically flips these upside down, right? Makes sense. It causes a reflection over the x-axis. So as x goes to infinity, y goes to, well, let's see, as x goes to infinity, goes to the right, y goes down. And as x goes to negative infinity, goes to the left, what happens to y? It goes up. So if you notice, these are flipped. These are the opposite as the ones up here. All right, and then you might already predict this one is similar. These are in a way flipped. Not exactly flipped, but we'll see what happens here. So as as x goes to infinity, as we go to the right, y goes down, goes to negative infinity. And then as x goes to negative infinity, y goes down also. Okay, so there we go. And this is the case for even if we, and then what do these look like? This is like negative x squared, negative x to the fourth, etc. Okay? So, yeah, this pattern holds no matter how high the degrees are. Now we're going to use this knowledge to actually work with these problems down here. So we're asked for each polynomial function below, identify the degree and if it is even or odd, the sign of the leading coefficient, and then the end behavior, which we can get the end behavior based on these previous two things. All right, so let's take a look at f of x equals x to the sixth. Well, let's see, that is, the degree is going to be 6. And, of course, that's an even number. So it's an even degree polynomial function. We have to identify the sign of the leading coefficient. Well, it's positive. So we'll just say LC for leading coefficient is plus. Leading coefficient is positive. Based on that, we can write the end behavior, because every even degree polynomial with a positive leading coefficient, they always have the same end behavior, and that's in our handy-dandy little table up here. So we look for even degree and positive leading coefficient. That'd be right here, right? Positive leading coefficient, even degree. So we can, this is going to be our end behavior here, right? It's going to be going up on both sides. I always think of just a basic quadratic here, x squared. All right, so let's go ahead and write down that end behavior as x approaches infinity, y approaches infinity, and then as x approaches negative infinity, y approaches infinity. All right, there we go. End behavior for that one. Let's take a look at number 2. Now this one is in a different form. This is in intercept form. All right, number 1 was standard form. Number 4, by the way, is also standard form. 2 and 3, though, are in intercept form. So to get the degree, it's a little bit different. We talked about this in the last lesson. You have to see how many x's are there total. Like if we were to multiply this out, what would the highest exponent be? Well, that'd be 2, right? 1, 2. So the degree is 2. And of course, 2 is an even number. So we have an even degree polynomial. This time the leading coefficient is negative because of the negative out here. All right, now we write down the end behavior. So well, let's see, we could use our table to see what it is. Now eventually you guys will have to just know this. You won't have the table in front of you. But right now, since we have the table, we're still just learning this. We'll use it. So yeah, an even degree polynomial that has a negative leading coefficient looks like this. Think of like negative x squared, right? That's going to be like a parabola that's heading downwards. So on the right and the left, it's going to negative infinity. So yeah, as x heads towards the right to infinity, y approaches negative infinity. And similar for when x goes to the left towards negative infinity, y goes to negative infinity. All right, we're going to do another pause, and I'm going to let you guys do 3 and 4. All right, so hopefully you did 3 and 4 on your own. You're going to get the most out of these lessons if you put the video on pause, do them on your own, rather than just like watching the video. You're not going to get as much out of it. All right, anyhow, here's the answer to number 3. The degree is 3. How do I get 3? Well, again, you count this x twice because of the 2 up here. So 1, 2, and then one more x, 3. So degree is 3. That's odd, of course. The leading coefficient is positive. There is no sign here, meaning it's positive. So leading coefficient is positive. And you can either use your table. Usually what I think of, these new cubics that we learned pretty recently, this is a cubic. And I know they look like this because it's a positive cubic. Leading coefficient is positive. So this is the end behavior. But you can use your table also. So yeah, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. Okay, number 4. The degree on that is 5. That's just the highest. This is in standard form, so it's just the highest exponent of any of the variables here. And yeah, the degree is 5. Oops, I forgot to say that is odd. That is odd. And leading coefficient is negative. And so you could either use your table again, or in my brain, what I think about is like x cubed. I just kind of know by heart that way. But if it's negative, it goes this way. Okay, so x to infinity, y goes to negative infinity, right? And then as x goes to negative infinity, y goes to infinity.